5.4 notes, day 2. Okay, I got one more example for you. It's got a little bit length to this example, so bear with me here for a second. Two surveyors are measuring the height of a mountain. The angle of elevation from surveyor A is 37 degrees 46 minutes, and the angle of elevation from surveyor B is 40 degrees 30 minutes. The distance between surveyors is 1,000 feet. How high is the mountain? All right. Get all that down? Two surveyors are measuring the height of a mountain. The angle of elevation from surveyor A is 37 degrees 46 minutes. The angle of elevation from surveyor B is 40 degrees 30 minutes. The distance between the surveyors is 1,000 feet. How high is the mountain? We're assuming a couple things. First, we have to assume that the surveyors are at the exact same elevation, which happens to be the base of the mountain. Make sense? We need to draw a picture. Does everybody have this copy down? All right, we got a mountain. Snow at the top. All right, we got surveyors out here making checks. Okay, they're surveying the top of the mountain. Right? So, what we can do is this. How's that? So there's our triangles. We actually have two triangles. Now they didn't tell us. We know the distance between the two surveyors is 1,000 feet. Which surveyor is which? Which one's A, which one's B? How do we know?
Since one is we look for the 37 degrees and 20 degrees.
What do you mean, which one? Whichever one looks like it. It's not a matter of what it looks like. I mean, this is a sketch. It's not drawn to scale. It's not going to be perfectly 37 degrees and 46 minutes. We could do that, okay, but you should be able to tell me which one is which based off of the angles. I agree. Which one's which? B is here, and A is here. So you're telling me B is 40 degrees, 30 minutes, and over here is 37 degrees. Actually, let me draw it outside. 37 degrees, 46 minutes. Correct? Okay, try, how's that? Okay, so, which is true. That has to happen. Okay? The angle that is smaller is going to be on the outside. Okay? Closer you get, the more the angle should be. So the smaller angle goes further away, bigger angle goes closer. We have a height. We have no idea what the distance is from the surveyor to the center, to basically where the perpendiculars drop from the top of the mountain. But I think we have enough information that we can figure it out. So let's set some triangles up here. Let's split these two up. We have a big one, and we have a littler one. B, A. So we got 37 degrees, 46 minutes. And we have 40 degrees, 30 minutes. We have a common height. This is x. What's this distance going to be from A to that base, to that center, however you want to call that? X plus 1,000. Very good. So we have a common h. We should be able to solve for h, set them equal to each other, and solve. Looks like we're going to use what? What trig function in both cases? Tangent, I agree. So tan of 37 degrees, 46 minutes is equal to h over x plus 1,000. Tan of, didn't show up, 40 degrees, 30 minutes equals h over x. This is going to be fun. X tan 40 degrees, 30 minutes equals h. Let's go ahead and put this x plus 1,000 up on the other side, get rid of the fraction. Tan 37 degrees, 46 minutes equals h. Does everybody follow what we've done so far? These are two separate parts right now. Well, they're both equal to h, so how about we say x plus 1,000 times the tangent of 37 degrees, 46 minutes equals x tan 40 degrees, 30 minutes. Do you agree with that? They are both equal to h. So we can set them equal to each other. Yes? All right, we just got to solve for x now. Are we ready to move on? Are we still copying? I'll give you 30 seconds. We're going to distribute this tangent. So I got x tan of 37 degrees 46 minutes plus 1,000 tan of 37 degrees 46 minutes equal to x tan 40 degrees 30 minutes. So all we do is just distribute this right here. Okay, to both. Everything that has an x in it should move to the one side. So x tan of 37 degrees 46 minutes minus x tan 40 degrees 30 minutes equals minus 1,000 tan of 37 degrees 46 minutes. Or we could have moved the x tan over. It doesn't matter which side you move it to. Left, you can move that to the right or left, whatever you want to do there. Factor out an x. And then divide. Just a little bit of algebra there. All right. Negative 37 degrees 46 minutes. Notice I put the top in parentheses. Divided by tan 37 degrees 46 minutes minus tan 40 degrees 30 minutes. So the top is in a parenthesis. Actually, I forgot a parenthesis, didn't I? Okay, so I have a parenthesis around the entire top. The trig functions automatically put a parenthesis on it, so you have to close that one off. And then on the bottom, I'm going to put one more in the end here, so I have a parenthesis around the entire bottom. Some people think that's not necessary. I like to play it safe. I think it is. So, that doesn't like me. I'm in the wrong mode. The negative 1,000? It was positive here. When I moved it over to the other side, I subtracted it over. Yeah, I guarantee I'm in the wrong mode. Let's see here. Yep, we're going to go degree mode. Okay, so let's recall what I did. That's a little bit better. 9765.826 feet. What did we solve for? What do we want to know? Are we done? Let's finish it. We found x. What do we need? Right here, h. X tan of 40 degrees, let's put it right here. 30 minutes equals h. So I'm going to put in 9765.826 times the tan of 40 degrees 30 minutes That's equal to h. So h is what I just had. So I'm just going to say my answer times a tan of 40 degrees, 30 minutes. So there it is. 8340.803 feet is the actual height of the mountain. Now, we could have tried solving for what first? We could have tried solving for x and eliminated x to solve for h immediately. This is the way we approached it. There is another way you can approach it as well. You can try that. Okay? Do you have any questions on that? Yes? Yeah. I'm good. Completely out of the way here. How's that?